Hello everyone, welcome to Moonkids. Today we'll find out how we can query these files directly to get the data. Now in some cases we don't need to create views, tables, temporary views, and we need to find out what the data is there in the file. So there is one way you can do that by using Spark SQL syntax, and in a few moments we'll find out how. So I am in a data science and engineering persona. Let's find out whether we have the compute instance running. It is running. Go to workspace. Let's create a new notebook here by the name of querying files. And let's keep it as SQL. Okay, so now we have our notebook ready. We have our compute instances. Let's do one thing. Let's make it as Python, and then we will switch using our magical commands for the SQL syntaxes. Let's find out whether everything is okay or not. Print is working, cluster is there. So yeah, the print is working, is fine. Now let's find out how we can read the files uh, directly using the SQL syntaxes. First of all, we need to find out whether we have data or not. We'll go to data. Now here we are considering the data what is stored in the DBFS, which is Databricks file system. So for the guys who cannot see this DBFS over here, let me show you how you can have it. Go to admin settings, go to workspace setting. In advanced, you'll find DBFS file browser enabled. So initially when you start working, it's always disabled. So if I disable it, I go to my data option again, and I will not be able to find DBFS here. So no DBFS is there. So now to make it enable, to make it visible over here, I'll go to admin settings, go to workspace setting, DBFS file browser enabled. Now when I refresh this one, I may be able to get DBFS button over here. So this is visible now. Let's click Browse DBFS. Now here I have loaded some files. Now this is a Databricks file system where you can upload some data file to explore it, to find out how you can work with the file. If you want to do some kind of experimentation, you can do that here. Normally, we pick up the data directly from the files which are available in the blob storage or in the buckets, AWS bucket, or somewhere in the external sources. The best way going forward, which Databricks recommends, is Unity Catalog. Now, Unity Catalog is the one process which we are going to use in future to make connection to the outside world and read the data directly from there. But so far, let's stick with DBFS. Now, in DBFS, I have uploaded some of the files over here, which are the CSVs and JSONs. And let's find out where these files are in our notebook, and let's start working with it. Let's go to recent. We did not save the file, I suppose. I go to workspace, user, Munish. Okay, I don't think so. I did create it over here. Okay, let me create a new one. I'm going to my folder again, and I think it's there. Querying files as was the one. Okay, so the notebook is there now. So let's find out where the files are there in our file system. There's a command called dbutils.fs for file system.ls, and now we'll find out where the files exist. Okay, to make it prettier, let's use the display command, and display. It will show me all the files on the root folder. Okay, so now we have these files, so I need the files in file store. So if I go file store, I think it's tables afterwards. Let me click this one. Okay, tables, we have CSV and JSON. Let's find out what is in the JSON directory and then read the files. JSON, Okay, so these are the files what we have. Now we'll find out how we can read the contents of the file without creating any view and table. We will create a view and tables later on, but let's find out how we can do that. So there is a command called select star from. If you see, the syntax is not visible over here properly because our cell is Python. Now to make it for SQL, we can use some magical commands. Once we use SQL here, the SQL will convert here and this will be highlighted. If I remove this again, you'll find it's Python because on the notebook level we have Python, but on this particular cell level I want SQL. So once I write SQL here, moment I write over here, it will convert to SQL and this will be highlighted. Now select star from. Now what will happen now? We need this file. How we can see that? Which format the file has? JSON. JSON dot backtrack and this file name. So once we trigger this one, we'll be able to see the contents of this file. So what we have done is we have find out which particular format the file was, and then we have given the complete path. If you can, this one, sorry, if you highlight here, so it will give you what basically is a JSON database Hive. It will land up to Hive metastore.json. I will explain you where it is, what is Hive, and what, if we create a VO table, whether it will get stored over there or not. Now, if I trigger this command, it will display the data which is present in this JSON file. Now, if you see here, we have not created any view or any table on top of it because previously in other environments like in data lake, those environments we basically have to create some kind of a structure to read it. But here it is quite easy. Just we can query the file directly here. See, we are able to see the contents of the file over here. Now, JSON is a structured file, and that is one of the reason why when we query the file, the data what we received back is also in the structured format. That is not true on those text and CSV files, but that we'll pick up sometime later. But so far, if you can see here, this is one of the best way to find out the contents of the file before using that file for your batch purpose and all. If you want to do some experimentation, you can do that. Now, how many records we have? We have 233 records. Now, see, it is so easy to query the file directly. Now, what will happen if you want to read all the files in one go? Normally, you create a loop, you make one file, and then you keep concatenating the data of one file to another. But in this case, in our Spark SQL, it gives us the option of specifying just the folder, not the file. Now, in this scenario, what will happen? Everything what is in the JSON folder will be picked up and will be displayed on your screen. Now, how many files do we have over here? If I pick up this location, if I go to my dbutils command .ls and okay, let me make it in a better way. The printing should be in the better way using display command. So these are the files we have. So now when I trigger this command, it will pick up all those files and it will show in the console. So now we got 2710 rows because it has picked up all the files from one folder. But over here it is picking up only one file, which is 004, and that is why we only have 233 rows. So let's go back. I'll explain you again what I have done to read the JSON files in one go. First, we need to find out where the files are. Once the files are available, you know the path where the files are. Either you can read directly the file by giving the complete path, and once you have that file, you can read it file by file to see the contents, or if you want all the files to be read in one go, then you can give the path of the folder. So all the files will be picked up underneath that path. Now this is one side of it. Now if you want to create a view on this one, can you able to do that? Let's find out. Yeah. There is one way you can create a view, a temporary view based on this query, because this is a one select statement. The data is not getting stored over anywhere. But if you want to analyze it, you want to see where the data is, there are few ways. You can create a table or you can create a view. But before going back, I'll show you what my Hive meta store is. The Hive is basically keeping the table definition or the view definition of what we create. Now here we have these existing one. Let's create a view here which is based on the data what is given in these JSON files, and let's find out whether that view gets created, whether it is visible over here or not. We will see the properties later on, but let's first create the view. Create or replace view, uh, raw data underscore one, read underscore one. Okay, it is having the Python cell, so we have to use our magical command. Now we need to pick up everything over here. Okay, so what we have done is create or replace view, then as select star from this. And if we create this raw data read one, there is nothing over here with raw data read one. Now let's find out whether it is able to create a view or not. It's it's working fine. It's okay. Now it has created a view. Now if I come over here, now if I refresh this data hive store, we will be able to find a read data read one. So here also you can see what the columns are, what sample data is. So those kind of information is visible over here also. And here if you want to find out using SQL command, you can also use select statement and %SQL select star from read one. Let's see what it gives us. See, there you are. Now it has read everything from this view. Now this view is basically is over here, and we have populated this view based on the data which were placed in the complete set of folder which has many JSON files over there. Now, in some scenario, you need to create a view, but you don't want to list that view in the Hive meta store because Hive will be persistent, so you can use it in other Jupyter notebook also. So what you have to do is you can make use of temporary view. Now, if I come over here, if I do create a replace temp view and around this, I'll make it as temp data read one. Now, if I click this temp data, temp view definition, we'll find over here that the view still exists. If I query this view over here with temp data read one %SQL, if I click this query, if I trigger this one, we'll get the data over here. So that means the temporary view exists. But this temporary view is only the scope of this temporary view is on this Jupyter only. So if I go to the Hive meta store, if I refresh this Hive, if I refresh this meta, I will not get the name of our temporary data read one over here. Okay, so this is the way you can create a view, or you can directly query the data file. Either you can read the data files directly, or you can create a view over here. Either you want the view to be stored in the Hive meta store, or you want a temporary view which is the scope of which is only for this Jupyter. You can do that. Now if you want to describe table, describe temp data read one. Okay, so describe, if I do extended option, it will give me more details about the file. Now this is the view which is giving me the column name and all, but if I go with the normal view, not the temporary one, if I do the raw data read one, now it gives me all the option of what the column names are, as well as it show me that it has stored in the Hive meta store. Catalog is this one, database is default, we have not changed the database. uh, this is the owner, and if you see all the information is given over here. So with this, if I remove this extended one, if I do this one, it will only give me the details of column names and all. But if I use extended, it gives me the option. It shows a lot many details than only the column names. It will show where the data is stored and what kind of a view it is. So it is over here. The details is over here. Now this is a JSON part. Now JSON is one of the format, but I think the most commonly known format is CSV format. And in CSV, the way we have read the JSON file over here, like specifying what the file type is, and then dot, then the complete path. Let's see if it works well for CSV or not. JSON has a structure, so it is a formatted file where the data is stored in a structured way. So when we extract data from JSON, it comes in a proper tabular form, but it is not exactly the case with the CSV files. We'll find out what exactly the CSV files look like and what we can do to make it populate in a proper tabular form. Let's move further. Let's find out where we have our CSV files located. So I believe it is file store tables. Okay, I think this is not existing. Let's go back and find out the complete path. So this is the one. So okay, so display file store JSON is, let's find the CSV. Okay, so we have our CSV files over here. Let's pick up one of the CSV file and let's do the same thing what we have done for JSON and find out what is the difference and what we can do further to make it read in a better way, or make or to represent in a tabular form in a better way. So okay, first we need to magical command SQL select star from. Now this all CSV files can analyze under the category of text. So text, then we give the complete path. Okay, let's execute this one. So what we get is like, see, all the rows are in a single cell. So all the columns, sorry, are in a single cell. So every the tabular form what we got in our JSON is not over here now. See, all are in one row for all the record. Here it is per field was in each cell, so it was a better representation in a tabular form. But in the CSV, that's not the case. Now select star. If you want to see the data, just high level data, how the data looks like, you can make use of this one. But I think there is a better way. There's better thing, like if we get the data in a tabular form, so we can have a good idea about the fields also. So let's find out how we can do that. So now we are going to create a table here which will make use of a using clause, and it will give you us the options of writing those keys and values also. But let's go and practical and find out what we can do. So we can go for create table. I think I have in one of the lecture I have used that also. Let me pick up the structure testing. Okay, this one. So yeah, let me pick up this SQL, paste it over here, and we want SQL. So what we're doing is create table if not exist or underscore one. Um, so what we are reading over here is index, organization ID, and number of employees. This is what we have. If you see here, the ones which have spaces are represented in this way. So what we are doing here is we are creating a table. If it doesn't exist, gets created. If not exist, and if we are specifying a schema over here. With the schema means like the field and the field type is mentioned over here. Now using CSV, as this is a comma separated value, so we are using CSV. Now options is header true. If you see here, this also has become one part of the record, but it's not as a header. So we are saying that header is in the file, delimited by comma, because if you see the records are delimited by comma over here, and location is this one. Now if you see here, while creating a view, let's go back. I'll paste the statement one after the other. Create temporary view, the normal view. If you see here, there is a difference. I'll show you the difference here. See, the difference here is this one, using CSV. First of all, that we are using CSV here, we are not defining anything. Second is options, where options is specifying whether the header is true or not. There are many key value pairs available, but for us we just want the header, and we want to tell the query that the delimiter is comma, not pipe. Now location is important. Now here the location is something what we is given over here after the from. So we are giving the location as one of the file over here, and we are creating a table. Let's trigger this command. Okay, so we have specified the location, and over here we are creating the table. First of all, let's find out whether org1 now exists or not. Let's go to data, Hive Metastore, here org1. Now in org1 we don't have the data. Sorry, we do have the data, but org1 was not available. Now let's go to our query. Let's find out whether the org2 is not there. Let's find out what we can do to make org2 available, because maybe org1 was already there, I don't know. So I'm just changing it to org2 and executing this query to find out whether org2 comes over here or not. Now let's trigger this command org2. Let's go back over here in data section, Hive Metastore, default, we have org2. So here also the columns are mentioned, sample data is there. Now here one important thing is once I describe table. First of all, before describing, let's find out what is in the table, organization 2. If I execute this command, I'll get the data over here now. So this is the data what is given over here in the input file CSV.txt. Now, if I remove this one, then what will happen? Will it pick up all the files in the CSV? Let's try. Okay, it has executed. Now, if I run this command again, org2, it is still showing you 1000 records. Let's refresh the table, or better is if I delete this table first. I'll show you in the next lectures why I'm doing this, because you need to refresh the data, because the data persistence in the cache gets picked up always. So let's find out drop table org_2. If it is still showing the record as 1000, so that means it has only picked up few of the files which are matching the schema what we have given over here. Let's find out. Let's create this table again. Let's go over here. Let's find out whether the date hive has org2 or not. We don't have org2. Now executing this query. Okay, we're not dropping it again, and select org2, and we have we have 10,000 rows now. So it has picked up all data. So I'll give you a more explanation about a refreshing data or when we append data, what we have to do before querying it. Do we have to refresh it? Because we can't recreate the table every time. So refreshing is one of the options we can use next time. Now see the difference is now we have 10,000 records. Now coming back over here, if you remember, we had one file. Now I'm just dropping this table again. I'm just commenting this part now. And if I execute this command, it will have nothing. Now, if I execute this command, which has only one file, so it will only have 1,000 records in place of 10,000 records. Now, let's see. So it has 1,000 records. So this is the way you can either read one file or you can read all multiple files. If I remove this one, then all the files under this CSV folder will be read. Now, if I describe this table org underscore 2 g underscore 2, what will I get? Okay, I get these options, which is normally the column name data type, but I want more details, so I will write extended. And then when I trigger this one, over here you will find, okay, now this is again the data with external details where the catalog is Hive Metastore, and we created time. The type is external here. Now I will show you in the next video what this external and managed table means and what benefits external has on managed and in what scenarios we use managed or external tables. So the location is given over here. Now here it shows you what is the delimiter, also what we have taken, what is header true. Now if we see this data is from one file, but if we remove the file name from here, if we give the only the folder path, then it will pick up every data from that location. So this is the way you can read CSV files as well as JSON files. JSON files. Let me give you a summary again. So here we are finding the file where the files are. Here we are reading directly from the file without creating any view or temp view. Here we are reading all the files under JSON folder. So you don't have to go one by one. You can read all files from one JSON, from one folder. Basically, like many files are there under this folder, so all the files will be read using this select command. Okay, going further, we created temp view. Temp view is visibility is only on just Jupyter. Once we have this node shut down, there is no temp view availability will be there for from this Jupyter notebook as well. And going further, we have created, okay, to show the syntax, so the properties of the table, we can use extended, because if we don't use extended, then we only get column names and data types. But if we need more details, then we can use extended. It will give us a lot more details than just the column names and the value. So then we have read one file. The file was not in a good way. The display was not in a good way. So we have used this using option and the options of specifying header true and the delimiter. And once we do that, we can read the files in a tabular form because we have defined our schema over here, what exactly the schema we are importing. And if you see here, this is picked up from the header of the file. So if I see here, if I see this one header, so these values are taken over here, and I have specified the data type also. So this is the way you can read directly from CSV or JSON file. In our next lecture, I'll give you the differences between managed and external and some other interesting topic. Hope you liked the video. Please subscribe our channel. Thanks for watching.